Yeah. So yeah. So example one. Write down the example one. So you understood this particular table, right? So if you understood this particular table, you have x of t is equals to 2j sine omega naught t. Okay. So you need to, so 2j sine omega naught t is what kind of a signal is this? J is coming means imaginary plus sine omega naught t is odd function. So imaginary plus odd function, what you will get if the signal is a x of,
Yeah.
so if the x of t is imaginary plus odd, what the c of n value you will get? Real plus odd only. Real signal plus odd only. Okay, so you can check it like this. See, if you'll break this form, this in the form of 2j plus sine omega naught t is e power, it is multiplied e power j omega naught t minus e power minus j omega naught t divided by 2j. Okay. Oh, let me,
Sir.
yeah, let me add. Yeah. So what I am telling, your signal x of t is 2j sine omega naught t. So this particular signal is 2j sine omega naught t. So this is imaginary signal plus odd signal, right? Sine omega naught t means odd signal and j denotes imaginary signal. If we will break this signal in the form of like this, e power j omega naught t minus e power minus j omega naught t divided by 2j, so this will get cancelled out. So what you are getting? You are getting e power j omega naught t minus e power minus j omega naught t. Okay. So yeah, you are getting these things. So what is the c1 value you are getting? C1 value is 1. And what the c of minus 1 you are getting? Minus 1. Okay, if you'll put in the formula of cn is equals to summation n is equals to minus infinite to infinite, right? E power minus j, e power j omega naught t. Okay, so that was the formula. I hope we discuss these things. C of n formula, or not this one, in this Fourier series exponential. Okay, so hashtag n is equals to minus infinite to infinite cn e power j k omega naught t. So these things we discuss. So this is means what I am trying to say, x of t is nothing but summation n is equals to minus infinite to infinite cn e power jn omega naught t. So we are getting this value only, x of t value. What we are getting? E power j omega t, e power j omega t minus e power minus j omega t. So minus denotes, so this, so c of minus 1 is minus 1, and this one value c of 1 is equals to 1. So what I am telling, so this particular c of 1 means you can directly say that if the signal is imaginary plus odd, you will get real plus odd signal. C of n value, real plus odd value you will get. Okay, real plus odd value. So this is real plus odd only. It's nothing but it's real plus odd only. How? See, c of n is nothing but c of 1 is equals to minus 1, c of minus 1 is equals to plus 1, c of minus 1 is equals to minus 1. This is real plus odd. Okay, real plus odd. Okay, now try this question. You can try this particular question what I am giving you. Just try this particular question. You have a question. This is your particular question. X of t. Okay. This is minus t by 4 to plus t by 4. This is t function. This is minus t function. Between this you are getting. Okay. This is a naught. And like that you are getting. Okay. So this value will be how much? Overall value will be t by 4 plus t by 4. So 2t by 4. So how much you are getting? T by 2. Okay. This overall value is t by 2. Okay. So your signal is from here to here. Okay. And suppose you are taking minus t and t. Okay. So suppose this is your particular signal. So how you will calculate? And I think if you are taking t in this particular point, so better to take a minus t here. Okay. So from minus t to t you are getting the graph in between this only. Okay. So this is your, what kind of a signal is this? Real, because real value we are getting only a naught value, real value we are getting. Okay. And this signal is even or odd? Put the mirror image like this. You are getting the same thing here also, like you check for cos. This is the first class topic only. So this is the mirror image of this. So this is the mirror image of this, means real plus even signal. So in the questions the answer they had given like this. C, option A is a naught by pi k sine pi by 2 k. Okay. And I'm giving two options only. Option D, a naught by pi k cos pi by 2 k. So what will be they are asking ck value. So if you are getting real plus even, so check the graph. If you are getting real plus even, you will get real plus even only. So in between this, like that, two option you will directly eliminate. So here suppose two option is like this, means you have option 1 and option 2. Okay. So if you having a real plus even signal, what kind of a signal you will get? Real plus even ck value only. So which is even? This is even sine? No, this is not even. Eliminate this. This particular cos is coming even function, and a naught by pi k is real function. So our option will be like this. We don't need to even calculate all the things. By checking the option only, which we mark the option D. Correct? We will mark the option D. So this, like this, we need to solve this type of questions. Okay. Yeah. Understood, guys? Is this clear? Is this clear or not? Prasanna, is this clear? Priyanka, is this clear?
Yeah, yes, sir.
Is this clear? Okay. Okay. So if it is clear, then we are moving for symmetricity. Next topic is symmetricities in Fourier series. See, trick cities in Fourier series. Okay. So you need to remember all the table. Okay. Then only you will able to try the solve. I will share the workbook now only. Okay, so see, you have a even signal, okay. So even signal means what kind of a things you will get? DC value or cos value. Example, for example, so Fourier series expansion, Fourier series, and these things will be used in a power electronics. So very important, Fourier series expansion of even signal does not contain sine term. You will not get any sine term after Fourier series expansion. Okay, if you are having a even signal, then you will not get sine term. Remember this, mark my word. Okay, same thing applies for odd signal. So in odd signal only sine terms will be present. Only sine terms will be present. Okay, in even signal you can get the DC value or cos value, but in odd signal you will neither get DC value nor get cos value, you will only get the sine term. Okay, because we know that average value of odd signal is what? Is 0. Okay, but it's not true for even signal. And what is the meaning of understood up to this? Means whatever the Fourier series expansion you are doing, after the expansion you will receive only the cos term in even signal, and in odd signal you will receive the sine term. In the even signal you may receive the DC value also, but in odd signal you will not receive the DC value. What do you mean by half wave symmetry? It's a very important half wave symmetry signal. Okay, so this is x of t. Maybe my voice is reflecting because I'm sitting outside okay, from the hotel. So this is kind of a signal, and this particular is like this. Okay, so see, this is 0, this is t naught by 2, means this particular point, and this particular point is t naught. It's minus t naught by 2, and this particular point is minus t naught. Okay, so what is the meaning of a half wave symmetric? Write it down. What is the meaning of a half wave symmetric? X of t is minus x of t plus t naught by 2. Means whatever the time period you have, you divide and you shift the signal. Either you are doing plus or minus, it's up to you. So if I am doing plus t naught by 2, so what I will get? This 0 will become minus t naught by 2. We need to subtract, and t naught by 2 will become 0, and this t naught will become plus t naught by 2, and minus t naught by 2 will become how much? It will become minus t naught.
Minus t naught.
Yeah. So the signal is going like this, okay, and this minus t naught will become minus t naught minus t naught by 2, so minus 3 t naught by 2, it will become like this, minus 3 t naught. Okay, now you are having that signal I am drawing 0 point is this, okay, it's going like this, means signal is became like this, it's became like this, okay, this signal only, means 0 value is this. So I had drawn with reference to this particular point. Okay, so this is my x of t naught plus t naught by 2. When I'll reflect this, means take the inverse, minus x of t naught plus t naught by 2, so you will get the signal like this. So whether you are receiving the same signal like upside, see, so this signal is coming like this only, so the condition is satisfied. This is the half wave symmetry. So when x of t is equals to minus x of t plus or minus t naught by 2, this is the time period, you are getting this kind of a situation, your signal is known to be half wave symmetric. In that kind of a situation, what happen, you guys know? In half wave symmetric signal, what the things are happening? Okay, so yeah, so in a half waves the above conditions will be satisfied, means like the above condition I need to provide you. Okay, see, if you have x of t is equals to minus x of t plus t naught by 2, okay, so what is the Cn value you will get? This Cn will be equal to minus Cn of e power j and omega naught t naught by 2, extra term will come, right, because of this t naught by 2. So what is the formula? If you guys remember, you can tell me what is the formula. What is the formula of x of t? Summation n is equals to minus infinite to infinite c of n e power j n omega naught t. Correct? Correct. If I am writing x of t plus t naught by 2, x of t plus t naught by 2, what will be the formula will come? N is equals to minus infinite to infinite minus x of t plus t naught by 2, so it will come minus cn e power j n omega naught t plus t naught by 2. Correct? If I am applying this, so when these things will be equal, so I am writing n is equals to minus infinite to infinite minus cn e power j, right, yeah, so okay, so e power j n omega naught t we can write into e power j n
omega naught t by
omega naught t naught by 2. Correct? Correct?
yes.
So yeah, so what is the meaning of this? This means, guys, this means if you will equate both this equation, if you will equate this and this, if x of t is equals to minus x of t plus t naught by 2, what you are getting if you will equate? So here also you are getting the same thing, here also you are getting the same thing. So what is the meaning? 1 is equals to e power j 1 is equals to minus e power j n omega naught t naught by 2, correct? E power j n omega naught t naught by t by 2, correct or not? Tell me, have you understood this particular thing? Have you understood, guys? Have you understood or not? Have you understood these things or not? Just wait. Have you understood or not, guys? Means what I am trying to do, I am trying to equate the equations x of t plus x of t naught by 2. I am just trying to equate this particular equations. So are you getting or not, means what I am saying? See what I did, this particular what I tell you, x of t is equals to minus x of t minus t naught by 2. So this is half wave symmetricity property. Okay, if when you will apply the Fourier series on x of t, exponential Fourier series, what will the formula? From n is equals to minus infinite to infinite c of n e power j n omega naught t, correct? And now these particular two equations are like we are choosing this graph, and we had seen that after shifting the things we are getting the same things. So now if I'll apply the Fourier series on this, minus x of t plus t naught by 2, what I will get? Negative term will get minus cn e power j n omega naught. Instead of t we will write the whole equation t plus t naught by 2. Okay, correct. And I am telling that x of t is equals to minus x of t plus t naught by 2. When you will equate this function and this function, so what you will get, this will get cancel out, cn e power j n omega naught t will cancel out. So what you will get, 1 is equals to minus e power j n omega naught t by 2, correct or not? Correct or not, guys? Tell me.
Yes, sir.
So
Extra t naught by 2 term will be there.
yeah, extra t naught by 2 terms
Got it,
will be
sir.
there. So this we are getting. Okay. Okay, so this is one, this particular, and write it properly because my pen is not working. So, and e power j n omega naught t by 2. Okay, now when you put the formula of omega, what you will get? 2 pi f, and f is 1 by t only, 1 by t only. So t will get cancel out, t and t will get cancel out, and here you have a 2, so 2 will get cancel out. So what you are getting? You are getting minus e power j n pi, correct? So when you will bring this side, so what will come? 1 plus e power j n pi equals to 0, correct? Guys? Okay, now you tell me when this value will be 0. 1 plus when our n is suppose my n is always an, if it will be even, whether we'll get the 0 value, Prasanna? If this n will be even, can we get the 0 value? Suppose n is equals to 2, what you will get? 1 plus cos 2 pi minus j sine
2 pi.
2 pi. So it will be 0 or not, means it will be 0. Just tell me, this will be to 0, but this will become 1. So 1 plus 1 will get 2.
But
So
which is not equal.
it is not equal to 0. But when n is equals to odd, when n is equals to odd function, okay, like 1, suppose 1 plus cos pi minus j sin pi. So it will be 0, means sin pi is okay 0, cos pi will be minus 1. So 1 minus 1
0.
will be 0. So what you understood? Half wave symmetric, only odd terms will be there. What you understood? In a half wave symmetric, only odd terms will be there. N will be odd terms will be there. So what is the conclusion? In a half wave symmetric, we'll get only odd terms. Correct? So
Yes, sir.
so Fourier series expansion of a half wave symmetric signal contains only odd harmonics. Write it down. Note point. Write it down. I can't write. I'm dictating. Just write it down. So Fourier series expansion of a half wave symmetric signal contain only odd harmonics. Okay. Contain only half wave symmetric. Have you written? Fourier series expansion of a half wave symmetric contain only odd harmonics. Second point, write the second point. So Fourier series expansion of a half wave symmetric contain only odd harmonics. If your Fourier series expansion of a even half wave symmetric, means your signal is even, but it is also half wave, means you having a even signal plus half wave symmetric, HWS. So if you have a even signal plus half wave symmetric, what will happen? The result will contain only cos term. So only cos term you will get with odd harmonics only, means n will be, all n will be odd harmonics, means 3, 1, 3, 5, like that. Okay. And if you are having Fourier series expansion even half wave symmetric, signal contains cos term with odd harmonics. Write it down. Fourier series expansion of even half wave symmetric signal contain cos term with odd harmonics. Okay, written. Now write down Fourier series expansion of a odd half wave symmetric signal contains sine term with odd harmonics. So this is, means if the Fourier series is a even, you will get and it is also a half wave symmetric, then the signal will be cos, means cos term plus odd harmonics. Okay, cos term plus odd harmonics. Cos term plus odd harmonics. Now what I am telling, if your signal is odd plus half wave symmetric, so what the Fourier series expansion you will get? So Fourier series expansion will be sine term. In this you will get sine term plus odd harmonics, sine terms plus odd harmonics. नहीं सही है, कोई दिक्कत नहीं. ओके आप रखवा दो कुर्सी. जी ओके. एक कुर्सी डाल दीजिएगा उधर. ठीक है. Guys, understood? So what I am telling, if your signal is having a odd plus half wave symmetric, then you will get sine term, because we know that we had learned this condition. If the even signal is, then there will be a cos term will be present. If the odd signal will be there will be a signal, there will be a sine term will be present. If the half wave symmetric is coming means n will be the number of terms, the number of n will be only odd. If both are coming, half plus even is coming, means you will get the cos, you will get the cos term plus odd harmonics you will get. Odd harmonics means like what we are putting in the function e power j and omega naught t. So only you will get only odd terms, 3, 5, 7, 1. It's like that you will get. While doing the example you will understand. Okay. And so this was the concept of odd half wave symmetric. Correct? This was the concept of odd half wave symmetric. Just wait for a minute, guys. Thank you, Via. Thank you so much. So, okay. Yeah. So, what is the? If I'll give you one example of a even half wave symmetric, see, you have an even signal like this. This is your even signal, okay, and it's like this. This is t naught by 4. This is t naught by 4. Write it down, t naught by 4. This function is t naught by 4, and this function is t naught by 2. Okay, this is t naught by 2, and this is 3t naught by 4. 3t naught by 4. This is 3t naught by 4, and this is t naught. Okay, and if you will check, if you will do the expansion like means what I am telling, for checking the half wave symmetric, you have to check like this: x of t plus t naught by 2, x of t plus t naught by 2, and taking the reverse, you will get the same signal. If you are getting the same signal, that means the signal is half wave symmetric, and this particular signal is even signal. Put the mirror like this. You are getting the same function this side also and this side also. So if the same part is coming in this side also, in this side also, then the signal is even. So this, yeah, so this kind of a signal will have when you will expand this signal. So x of t will contain only a1 cos, I am writing like this, a1 cos omega naught t plus a3 cos, whether this is omega naught t, the next term will be 3 will come, 3 omega naught t. Okay, so only you will get the odd harmonics because this is half wave symmetric, and only the cos term will be present, no sine term will be present, plus next term will be a5. What will be the cos 5 omega naught t? Next term will be a7 cos 7 omega naught t. Like that this signal you will get, and this is true. Okay, and like the same I am drawing one for a odd signal. So suppose you having an odd signal like this, like this is your triangular signal. So make perfectly. Okay, I am not able to draw. I am using my finger to draw this. Okay, because due to here temperature is very low, like that's why my tab is not working properly here also. So same thing is happening in Meghalaya. So yeah, so this is a triangular signal like this. Okay, I'm giving you the value. This is 0, this particular is t naught by 4, this particular value, and yeah, so this is t naught by 4, this is, so see, okay, this is T naught, write it like this only, this is T naught, this is 3 T naught by 4, 3 T naught by 4, and this particular is, okay, this is T naught by 2, sorry guys, this is T naught by 2, this is 3 T naught by 4, this is T naught. Okay, how you will check the half wave symmetric? You need to T naught by 2. What is the T naught by 2 value will be? This particular value is your T naught by 2. This particular value is your T naught by 2. When you will do the shifting x of t minus T naught by 2 and you will reverse the signal, you will get this kind of a graph only. And this is your odd signal. Put the mirror like this and check whether you are getting the mirror image or not. So even if you are getting the mirror image, so this is your odd signal. Okay, and this is half wave symmetric also. The conditions, you need to check the condition whether it is half wave symmetric or not by putting the mirror and all, you can check it. Okay, now what you will do, the term will be the same thing will become like b1, write it down in your copy, b1 sine omega naught t plus b3 sine 3 omega naught t plus b5 sine 5 omega naught t, like that you will get. Why? Because in odd signal we will not get the cos term. In odd signal we will not get the cos term. This is odd signal, so we will not get the cos term. Correct? Now, so yeah, this was the concept regarding I'm giving you a last kind of a signal. So write it down, question number 6. Let me check. Yeah. So question number 6 is like that. Give it to you like that. Not question number 6. It's a next topic, hidden symmetric signal. Okay, hidden, HIDDEN, hidden symmetry. Okay, SYMMETRY. Okay, hidden symmetry. What is the meaning of a hidden symmetry? Symmetricity. When the symmetricity will be even, we can say like a half wave symmetricity is even. Okay, so then this kind of a signal, how we will draw? Suppose you have a signal like this, a particular signal like this. Suppose the signal is like this, no negative term. It's like this. This is 0 value. This is T naught by 4 value. T naught by 4, write it down, T naught by 4 value. And this particular is 3 T naught by 4 value. 3 T naught by 4 value. Okay, and this particular is your T naught value. So how it's going? T naught by 4, 3 T naught by 4, T naught. Okay, now if you will do x of t plus T naught, what the signal you will get, guys? X of t plus T naught by 4 means T naught by 2. So T naught by 2, where will be the T naught by 2? In between this. Okay, 0 to T naught by 4, T naught by 4 plus T naught by 4, and so T naught by 4 plus T naught by 4, you will get some particular means some point here you will get T naught by 2. Correct? Some particular point here you will get T naught by 2. here or here, somewhere like in midway you will get t naught by 4 plus yeah. So t naught by 2 will be, and when you will shift this signal, when you will shift this particular signal, so this here 0 will come, 0 will come here, okay, then the signal will be, and when you will reverse this signal, when you will reverse the signal will be, okay, when you will reverse the signal, so signal will be like this, it will be look like this, it will not get upside. Let me correct it. When you will reverse the signal, okay, try by yourself, then only you will understand. You are taking this as a x of t, so 0 to t naught by 4, this particular midpoint is t naught by 2, okay, and when you are doing the reversing and all, means shiftings and all, so 0 is shifting here, so 0 is shifting here means you are getting the signals like this, somewhere like this you are sitting, and when you are reversing the signal, when you will do the reversing process, so your signal will be like this. So whether this signal and these signals are same? No. Whether this signal and these signals are same? No, it's not same, because we are not getting the positive part and here the negative part is absent. So how can we make this signal as a half wave symmetric signal? How can we make this signal as a half wave symmetric signal? How can you make it? So this kind of a concept is known as a hidden half wave symmetric signal. Okay, what you need to do, you need to make in the form of, like this, if you will make in the form of like this, then it's possible. Okay, how can we do these things? So suppose this value is 1, this particular value is 1, okay, can we do some this means we will subtract this signal, something like this we are making like this, yeah. So, and if we have this particular signal and if we'll add plus 1, okay, so suppose this value was 2, okay, I am taking this value was 2, this particular 2 value. So what I did, when I will subtract minus 1 from this particular signal, my signal will become like this, plus 1 and this is minus 1. All the upper side will be subtracted by 1 and all the lower side will be subtracted by minus 1 only. So signal will look like this, correct? So this was x of t signal. Now this signal we can write the same signal, this particular signal we can write x of t plus 1, correct? If we'll add plus 1 in this particular signal, we'll get back this signal only, correct or not? See what I am telling. Suppose I am showing with a very particular rectangular value only. This is your don't go for the things and all. So this value is 2. When I will subtract this, so this I am writing x of t, okay. So what I am telling, if I am writing x of t minus 1, so 2 minus 1 will be 1, correct? And this will also get minus, so it will go like this up to minus 1, correct? So this is my x of t minus 1 signal, correct or not? I did one subtraction from this particular signal, correct? I did one subtraction from this signal, then this signal will become like this. So this value, if I am writing this value as a y of t, so how can we express x of t? X of t is nothing but y of t plus 1, y of t plus 1. Okay, so we don't need to do with this one. Okay, this one means it's a constant DC value. Now we are getting a signal like this, means okay, so we can see this is a half wave symmetricity signal, okay, and this is a even signal also. So this particular y of t value will only contain even value means cos function, and because it is a half wave symmetric, will get odd terms only, like a1 cos omega naught t plus a3 cos 3 omega naught t, like that we will get, and plus some DC value, that is 1, because we shifted this hidden symmetricity in this form. Priyanka, getting or not? Means what I am trying to explain, are you getting? Prasanna, are you getting what I am trying to explain?
Yes, sir.
Okay, this is the part of the hidden symmetricity. Okay, so okay, yeah. So what we are doing in a hidden symmetricity? We are making the signal. In the form of symmetricity by adding some DC value. If we'll add some DC value like plus 1 or minus 1, our signal will become a hidden symmetry signal, like a symmetry signal. So with some DC value, we need to find the Fourier series of this that particular signal. Then we can do very easily the calculation and all. By seeing the option, we can mark the answer. So I am giving you up one particular example of the hidden symmetricity. You can do by yourself. See, one trapezoidal signal is like that. One trapezoidal signal they had given like that. It's going like this. It's going like this. It's going like this. It's going like this. It's going. So it's repeating. Okay. It's going like this, it's going like this, and it's repeating. Okay, this is a trapezoidal signal. I'm not able to draw perfectly. Okay, so the value means this particular value is 2, and the mid value will be so minus 1, not 1 only, and this value is 0. Okay, if we will subtract this signal, by 1, if this will subtract this signal by 1, we will get a perfect signal like this. Okay, one value. So this particular is cutting point. Okay, just take it like that. Okay, so the signal, if we'll subtract, so 1 minus 1, this particular is your 1 point. Okay, this particular it's touching, so 1 minus 1 will be 0. The signal will be like this. Okay, and it will go like this, now the signal will become like this after subtracting minus 1. Now you check the symmetricity, you will get the symmetricity. So this is your 0 value, this was your 0 value, this particular is my T0 by 2 value, and this particular is my t naught value. Okay, so this particular signal is y of t. Okay, y of t plus y of t. Okay, we did this y of t signal, and y of t signal is nothing but x of t minus 1, x of t minus 1. So this is my y of t, and y of t signal, how it's look like? See how it's look like. It is a odd signal, and when you will do y of t in y of t, when you will do y of t plus t naught by 2, when you will do y of t plus t naught by 2, so see, it will be also half wave symmetricity. So 0 will come like this, means your graph will become like this. It will become like this, and when you will reverse the signal, the same graph, when you will reverse the signal, it will go upside, it will go downside, so the same graph you will get, means the same signal you will get. So you can easily say my y of t is nothing but it is an odd signal, and it is also half wave symmetry signal. It will contain only sine term. So some value will come, like sine term will come, that too with odd value. Okay, so this is my y of t, and if I want to say about x of t, so these things to present, these things sine terms will be present, some odd value will be present, but x of t will be, we know about this signal, we just need to bring this one that side, plus 1, that's it, that is the DC value. So what we are getting in this particular signal, we are getting DC value plus sine term with odd function, we are getting. Okay, so that is the answer. They had given this signal contain what kind of a value? So DC plus sine odd term, DC plus cos odd term, DC sine and cos both are there, DC plus sine cos both are there. It's like that they had given the option. So you just need to make this in the half wave symmetry, check it if you are getting the mirror image or not. If the mirror image is coming like this, so this is an odd signal. Odd signal means only sine term will be present, right? Only sine term will be present. And because you make this signal in this form, how you make? By subtracting minus 1, then whatever the things you are getting, you need to add 1. So 1 means what? That is the DC value. That's it. Okay, so that was all about the hidden wave symmetry city. Okay, now we'll discuss not now because here some issue is happening, also tab is not working also properly, so we'll discuss these things maybe if I'll get the time tomorrow. So we'll get I will tell you that tomorrow is what the date? Tomorrow is 1, na? Right. Okay.
May 1st.
Yeah, May 1st. So May 1st. Okay, we'll discuss these things on, if the time will permit, then we can discuss it tomorrow. Otherwise we'll directly meet on 13. Okay.
Okay.
So just go through this particular things. Okay, so because means half wave symmetric, odd signals, even signals, the thing symmetricities in the Fourier series, just go through, just once revise this particular things, real signals, imaginary signals, and I will share the workbook problem. You need to solve this. All the concept is ready to chapter 4, up to chapter 4. Try to solve the workbook problem. Okay, and properties of a Fourier series is, means we need to learn linearity, time reversal, conjugations, time shifting, frequency shifting, convolution in a time domain, multiplication in a time domain, differentiation in a time domain, integration in a time domain, Parseval power theorem is there. Okay, So means like we had completed almost 45% of the signal system. Rest 55% will take like 15 lectures, we can say 15-16 lectures. Okay. Okay guys, thank you. We'll meet tomorrow or 13, whatever. If tomorrow the time will permit, I will take the class.
Thank you, sir.
Good night.